let's just talk about number one. I know you're probably still working on number two, but number one, the derivative of position is v. Yep. Velocity. What is the derivative of velocity? Derivative of velocity is acceleration. That's what you need to take away. Acceleration. Okay, now go ahead. For part A, how long will it take the ball to reach the ground? What do you have to do? What happens in the equation then? If the ball's hitting the ground, what do I know? I want to know how long. Yeah, where does 0 go? Think about what does S of t represent? The height. So I set the height equal to 0, right? That's when it'll hit the ground. So go ahead and do that. And then velocity, you need to find the derivative and then at that value, okay? Take a second. You guys can round to the nearest 10th if you want. Did you guys get a value for this? Okay, here's part A. You should have set it equal to 0. And you subtract 1667 divided by negative 16 square root. We ignore the negative square root in this case because it's time. And what are my units? I need to write units. T is in seconds. All right. Now, if I'm finding velocity, I just need to find the derivative of position. Velocity is the derivative of position. So that should be another like trigger word. Like when you hear velocity, oh, I think derivative, right? Derivative of position. So I'm just going to take S prime of t is the velocity. That is v of t. So I derive that. It's going to be negative 32t, right? Easy. The derivatives are easy. It's just you got to know kind of what to do. And then I want to find the velocity when it strikes the ground, right? So what do I got to plug in? 10.2 in for t, right? So it hits the ground at 10.2 seconds. So I'm going to find v of 10.2. So negative 32 times 10.2. Calculator. And you get negative 326.4. Okay, what are my units for velocity? Remember, velocity is derivative. How do you find the units for derivative? Units of y over units of x. So it's like slope, y over x. So what are my units for the y value for S of t? Is feet, yep. And then over seconds, yeah. Feet per second, it's a rate. Okay, does that make sense? All right, so as a recap, and we left off with example 3. So let's go ahead and continue that. Okay, so we have let's reorient you to this. S of t is the function. We are asked to find the acceleration of the object. I know that acceleration is the derivative of velocity. We found velocity in part B, I think. Excuse me. Trying to clear my voice so I can think. All right. So all I need to do is take the derivative of velocity. Get those packets out. Okay, derivative of velocity in this case. Here's velocity. That was what we had in part B. So the derivative is 2t minus 14. That is the acceleration function. So if I want the acceleration when t equals 4, what do? I find a of 4, right? The acceleration at time 4 seconds. So I plug it in. 2 times 4 minus 14. That's going to be 8 minus 14 is -6. Now, you want units. I'm going to ask you for units. What are units for acceleration? Yeah, it's something per something squared. So it's your, yeah, feet per second squared, right? Logan. So it's feet, or yeah, or did it say meters? Hold on. Oh, it's okay. Yeah, feet. Feet per second squared. All right, good. That's acceleration units. Feet per second per second. Okay, and then one more together. Look at the signs of acceleration and velocity and make a conclusion. In part B, we found that the velocity at 4 seconds. Now you have to evaluate them at the same t value, the same time value. The velocity was -16 feet per second. What do you think the acceleration is telling us about the velocity here? What do you think? If I say it's accelerating at -6 feet per second. Per second. Is the, like, let me ask you what you think. Is the velocity speeding, is it speeding up or is it slowing down? You think it's slowing down? Because they're both negative, right? Check out the facts I wrote at the very beginning of this. And it says when velocity and acceleration have the same sign, the object is speeding up. So if I'm traveling down, remember negative velocity just means direction. So if I'm telling you that your acceleration is also negative, that means the velocity is speeding up in a downward direction. Make sense? So if they're the same, either if they're both positive, it's speeding up and going upwards or whatever. Or this is horizontal, so that means the negative means it's going to the left. It's not falling, it's going horizontal. If it's positive, means it's speeding up to the right. So I can conclude that the particle, what is this for a particle? The particle is speeding up because the signs of acceleration and velocity are the same at t equals 4. And I'm sorry, I should qualify this. The particle is speeding up at t equals 4 seconds. Okay? The particle is speeding up at t equals 4 seconds because acceleration and velocity have the same signs. Okay? All right. Let's do the next problem. Impact velocity. Impact velocity is when it like hits the ground. Okay, we already kind of found it, but we're going to refresh you on what V sub 0 and S sub 0 mean. If a marble is dropped from the top of the Sears Tower in Chicago at a height of 1454 feet. The marble's height above the ground, t seconds after it's dropped, will be this position function. Write a position function and then find how long it will take for the marble to reach the ground. Okay, what is v sub 0? What does that represent? That is your starting velocity, your initial velocity. And then s sub 0 is your starting height, your initial height. So do we know what, let's talk about s sub 0. What's my starting height? Where am I dropping it from? 1454, yeah. Yep, 1,454, right? So I'm starting at 1454 feet. That's s sub 0. And what do you think my initial velocity is? I'm starting at what? 0. Yeah, you got it. I'm holding it and dropping it. So, so this is 0. So when I plug it in, s of t is going to be negative 16t squared plus 0t plus 1454. And we can just simplify that to the position function s of t. The height is negative 16t squared plus 1454. Okay, so that's the position function. And now it wants to tell you, or wants you to tell it, how long will it take for the marble to reach the ground? What do we do? What do we do? Set, yeah, set what equal to 0? S of t, position, right? So the height, S of t represents the height. So the height has to be 0 when it hits the ground. So S of t has to equal 0. So then we solve this. Okay, we do t squared is going to be 1454 divided by 16. And it's going to be the square root of all that. Get that calculator out. Right, because negative over negative become positive. So we're going to do 1454 divided by 16. And then we do the square root. We know we could do plus or minus square root, but because it's time, we're going to keep it positive. I'm going to do second answer, second negative sign to get that whole decimal in. I don't have to retype it, although my calculator is being laggy. All right, so 9.53. Let's round to the nearest hundredth here. It says, so 9.53 what? What are my units for t? So seconds, just t is going to be seconds, right? So I'm only solving for t. So I would say it's going to hit the ground at 9.53 seconds. Okay. All right. The next thing is, I made this a your turn problem. I want you to find in part B, actually, and C, go ahead and work on B and C. Find the velocity of the marble 1 second before it hits the ground. I have a purpose for that. And then find the acceleration 1 second before it hits the ground. Here. When I'm asked to find velocity given a position, what does it mean? Take the derivative. When I'm asked to find acceleration given velocity, take the derivative. Oh.
Yeah. I don't know why, but like.
Okay, these are tough. Calc-based physics.
So you find the derivative of this. Well,
That gives you velocity.
yeah, which would be the -38.
And let's label it. You want to label everything? That equals what? It's velocity. What do we use to represent velocity?
That means the F of t.
V, no, no, V of t is velocity. which is S prime of t. Those are the same thing. So it's S prime, which is the derivative, which equals V of t velocity. Okay,
And then, we don't have, we don't plug anything in.
well, I'm asking you to find it 1 second before it's the ground.
So you
So
just
what's,
subtract this by one.
so plug that in.
And then how do you do? Just the same.
How do you find acceleration given velocity?
You take this.
Derivative of that, yep. It's gonna be a constant. You guys get the velocity of combination? You wanna find that?
Yeah, but.
Okay,
you
remember,
minus one.
velocity is the
So
derivative
it'd
of,
be 8.53. This would be.
yeah, position, right? So, just take S prime of t, right? And that equal, I was right, S prime of t equals.
Negative
V of t, right? That makes it, that connecting? I'm gonna sing that song, it'll connect even more.
Yeah.
And so you just take the derivative. That's the velocity. Okay. All right, so let's chat. Remember, velocity is derivative of position. So S prime of t, the velocity function, we use V of t, don't forget. So it equals V of t, and that is negative 32 t, right? That's the derivative of S. And then we want to know, what is the velocity 1 second before it hits the ground? Well, it hit the ground at 9.53 seconds, right? So what do I plug in for t? 8.53. Did you catch that? 1 second before it hits the ground. So we're going to find V of 8.53. And again, I have a purpose in that I'm going to show you something interesting. So negative 32 times 8.53 is, calculate. Did you guys get negative 272.96? Yeah. And what are my units? What are my units for velocity? Units of y over units of x. So feet per second. Feet per second. It's like a distance over a time. So that's my velocity before it hits the ground. Now, acceleration, we'll come back to that. Acceleration is the derivative of velocity, right? Another way, so that's A of t is used to represent acceleration. Another way to write that is S double prime of t, right? It's the double derivative of position. It's the derivative of its derivative. So acceleration is easy. You just take the derivative of negative 32t, and that's going to be negative 32. What are the units for that? Feet per second squared. Okay. Now, let's go ahead and find it acceleration 1 second before it hits the ground. So I need to find A of what value for t? 8.53. Does that make sense or no? Yeah? Okay. Let's see more nods. 8.53 is 1 second before it hits the ground. So pop it in. Well, hey, what do you think the acceleration is at 8.53? Negative 32. There's no t there. So it's still going to be negative 32 feet per second. Do you understand? Like when acceleration's a constant, it's that for every value, for every t value. Okay. So, here's what's interesting. The next part, I'm going to try to make a connection for you. And I think this will be helpful. In part, whoop, did I skip D? What happened to D? You guys have D on your paper, right? Yeah, you know what? I'm just going to write D in. Part D is asking, I don't know why I'm missing that. Part D is asking, hey, whenever the velocity is a constant, there's two ways to find the velocity. We're going to first use part A in order to get the velocity. So we're going to use part A. So in part A, I know that it hits the ground at 9.53 seconds. So if I want to know the velocity v of t when it hits the ground, I'm going to do what? My velocity function is negative 32t, right? What do? I find v of 9.53 seconds, right? It hits the ground at 9.53 seconds, so I want to find the velocity at impact. That's your impact velocity. How fast is it going when it splats on the ground, okay? So negative 32 times 9.53. So we found this. You guys did this in the bell ringer, so very similar problem. So I just hit negative 32 times 9.53. If I want a more exact value, I could just multiply it by that whole decimal. But I got negative 304.96 units for velocity. You got it, feet per second. The more you say it, the more you remember. Okay, now, this is interesting. I can get the same value when acceleration is a constant. If I look at it, do you see we looked at it a second before it hit the ground? And I told you that when acceleration and velocity have the same signs, right? You see this negative 32 feet per second squared is acceleration and negative 304, right? They're going to be, that means the velocity is speeding up. So if I take in part E, I'm going to use what I found in parts B and C to estimate the velocity when it hits the ground. So here's what I knew. In part B, I know the velocity a second before it hits the ground is negative 272.96 feet per second, right? I also know the acceleration at, that same value, sorry, at 8.53 seconds is negative 32 feet per second squared. What does that tell me about the velocity? The velocity is speeding up at a rate of 32 feet per second. So how do you think I get the next value at 9.53 seconds using the acceleration? What do you have to do with these numbers? Yeah, right? Yeah. So this only when acceleration is a constant, 272.96 plus the negative 32 acceleration, right? That means the next second, 9.53 seconds, the velocity is going to be, well, what is that? What is it? Negative 304.96, negative 272.96 minus 32. Gives you 304, oh, we'll talk. Okay, negative 304.96 feet per second. Let me recap to show you kind of what we did. I'm going to zoom out here. We found the velocity at impact two different ways. And I just wanted to show you how acceleration and velocity connect. So if I ask you to find the velocity impact, I'm probably going to find the t value where it hits the ground, which in this case was 9.53. And then I would find the velocity at 9.53 by taking the derivative and plugging in the time, 9.53, and then getting a value. That's the easiest way to do it. The only reason I made you do this, and I'm not really going to make you do this again, I don't think, but the only way I made you do this is so that you know that acceleration, the second before, right, is telling you, hey, if you find the velocity for one more second, right, it's going to be 32 feet per second faster for one more second, right? That's negative 32 feet per second. Because they have the same sign, you know, it's speeding up at exactly 32 feet per second, okay? So my point is the derivative tells you about the original function, right? Velocity tells us about position. The second derivative tells us about the first derivative. So acceleration tells us about velocity. Make sense? Okay. Are you guys ready for the song? Okay, we'll skip your turn 4. And just so you know, I recommend you need to do worksheet 5. You need some practice with this. Okay. So